Hello, welcome to Easy Math. My name is Zishan, and today we're going to learn about distance time graphs from IGCSE Physics 0625, topic number 1.2, motion. So first, let's start by defining what like understanding what a distance time graph is supposed to be. Well, it's a graphical representation of the relationship between the distance moved by an object and the time taken to travel that distance. You have usually time on the x-axis, time in seconds on the x-axis, and you've got the distance that the object has moved on the y-axis. Now, the points on the graph represent the time, for example, at 10 seconds in this case, and the distance the object has traveled in those 10 seconds. So it may be at 35, this may be at 20 and 70 maybe. This can be at 30 and 105. So what you're looking at is a straight line which represents the motion of this object. So to repeat it, you have the time taken by the object and the distance it has traveled as the coordinates of the points which create that point. Okay. So now the most important thing in um, this portion of the subject uh, is about speed of an object, how to interpret the speed of an object by looking at the distance time graphs. Well, for that, there's one very important thing that one has to know. It's the fact that gradient of a curve on a distance time graph is equal to the speed of the object. Now, for that, one has to understand what gradient of a curve is. So, yes, we do get gradient of a curve is supposed to be the speed of an object. But what is a gradient actually? So, we're going to draw a few curves here. Let's see, we have a curve which goes like that, a curve which goes like that, and a curve which goes, let's say, this way, and there's one which goes like that. Well, what I see with the curve here is that it is flattening out. So if I draw tangents to the curve at different points as I go, so I see that the tangents are flattening out as I move ahead in time. So what this means is that the speed is reducing as you're going. Now, that in itself is a decreasing speed being shown, decreasing speed being shown on a distance time graph. Decreasing speed is literally deceleration. So you're looking at a decelerated motion, a motion which has its speed reducing. Now let's look at this one. Well, again, a distance time graph, but I see that the tangent when I draw it at various points on the curve, the tangent is actually sloping upwards. The slope of the tangent is increasing. Well, that's when you have speed increasing. And you call it accelerated motion. Well, look at this one down here, the third one we have here. When I draw tangents, trying to draw the tangents to this curve, I see they're going to be straight lines. The tangents are all straight. They're not changing their slope. If the tangent doesn't change their slope, it means that the speed has been constant, has been constant. So what you're looking now at is a constant speed motion. You can call it a uniform motion. Now let's look at this one. Fourth, what we have here is at different time values, the distance, which is to be read from the y-axis, is not changing. So what you're looking at is a stationary object. And that is how you figure out the speed of an object by looking at, like you describe how the speed of an object is changing looking at the distance time graph given to you. Okay, now what comes next is being able to find the speed of an object by looking at the graph. But this time they're going to give you a time value. For example, they can give you time equals 10 seconds, time equals 5 seconds. So you're going to have to find the speed at that value of time. For that, let's take you to a curve and we'll try to figure out the speed there. So there. This here is a curve which represents the distance time relationship between distance time relationship for an object. So we're going to name the axes. So we go distance on the y, we got time in seconds on the x-axis. Now, let's say they have asked you to find out the speed when time was 6 seconds. And also when time was about 16 seconds. See, there's a trick to it, and you have to remember the trick is to draw a tangent to the curve at that time value. So I'll try my best with the tools that I have on Zoom to draw a tangent to the curve at that time value. So obviously this is not a tangent. So we're going to have to go, okay, very close. Yeah, there. So I'm going to extend it. Yeah, somewhat like that. So here we go. There. That's a tangent drawn. Now, what you do is you look at find out the gradient of this line. How do you find out the gradient of this line? Well, I'll read out the values. For example, there's a 10 x-axis, x coordinate of 10, and corresponding to that, I have a y of about, so you go 3.5. So 3.5 on y, and then you go take up another, there is a 3 0. So you find out the gradient of this line. The gradient in this case is going to be 3.5 y2 minus y1 divided by x2 minus x1. So you go 3.5 divided by 7 comes out to be 0.5 meter per second. Well, that's the speed of the object. That's the speed of the object when time was equal to 6 seconds, meter per second. That's it. Wait, I did a mistake in the coordinates that we were reading, and it is very important for you to know that the coordinates should be read right. There are marks in the marking scheme allotted just to read the coordinates right. So I'm going to make sure that I tell you what it was. Well, I read the y coordinate to be a 3.5. Well, it's not a 3.5. It's somewhere here. It's actually a 2.5, a 3, and a 3.5. So it's actually right in between 3 and 3.5. So it's about 3.25. And that is why the speed now would come out different. It's going to be a 3.25 minus a 0 divided by a 7. And of course, this value will also change. So that was it. We can go back to the video, just saying that the coordinate here was wrong. Okay, you can continue with the video. I'll see you. Yeah, now we have the things on notes. These were the things that we were looking at earlier. And now this is the whole method of finding out the speed at some time value. Now we're going to go back to the graph and we're going to find out the speed when time was 16 seconds. So there's your curve when time was about 16 seconds. Yes, there we're going to draw a tangent again. and we go there like that. So you go. It may look a little slow for you right now, but trust me, it's really easy when you have a ruler with you. I'm trying to use the tools on Zoom to do it. That is why it's taking a while. So here, okay, so that's the best I can do with Zoom right now. And there. Okay, so I'm going to extend the line for me to see a few reasonable points which are easy to find the coordinates of. So somewhere there, and there, let's extend this thing. Yeah, goes somewhere there, and there, this is enough. Now we can go look at one point. Let's say we can do a 20. Oh no, 20 is not nice. We can do a 18. Well, there, and you can do a 14 also. And from corresponding to 14, we have a 7.5, I think. And corresponding to 18, we have a 12.5, I think. Yeah, 12.5. No, there's a 13, 12.75, I think. Okay, so let's go check out the values. Here's a x value of 14. Corresponding to that, we have a 7.5. 7.5, and here you have an 18, and there you have a 12.75. So let's figure out the gradient now. So time equals 16 seconds. The speed is gonna be the gradient of this dt curve. It's a 12.75 minus a 7.5 divided by 18 minus a 14. So you go calculate it. 12.75 minus a 7.5 uh, minus a 7.5 divided by 4. So that's a 1.3125 meter per second. Okay. And also let's take a screenshot and paste it on the notes. There it is on the notes. Now, what I want you to see is the difference we have seen in the speed when we calculated it for different time values. When time was a 6 seconds, the speed came out to be 0.5 meter per second. And when time was 16 seconds, the speed came out to be 1.3125 or 1.31 is good enough. Now you can actually see that the speed has almost doubled itself. From a zero point 0.5, it went to 1.31, almost 3 times what it was. So yeah, I would say that was actually visible. That change, which was actually visible in the curve itself. We had to find out the speeds though, but we can see that the gradient of this speed time curve was increasing. You see that the tangent was sloping upwards. It was inclining more and more away from the x-axis, with that being the x-axis. So yes, the speed of this object was increasing, and we actually saw it, a 0.5 somewhere around here to a 1.31 somewhere around there. So that's it. These are the things that you should know about a distance time graph. And we can sum it up starting with the definition of it. Well, what it really is, it's just a representation of the distance moved by an object and the time taken for it. Gradient of a curve on a distance time graph is equal to the speed of the object. And these are a few curves explaining the motion. You're going to have to understand how the curve goes down. If the curve goes down on a dt curve, it's a decelerated motion. If the curve goes upwards, it slopes upwards, it's speed increasing. And here, if it's a constant gradient, meaning a straight line like that, it's a um, constant speed motion. And this one is a stationary object because the distance has not changed with time. And there was one other trick. So for finding out the speed at various time values, I showed you two examples. That's about it. Only 2 or 3 things for this video, and that's all. We'll see you with speed time graphs next. Speed time graphs, and there are a lot of things in there. There are uh, uh, more important points which are being asked in the exam uh, from the um, speed time graphs. I'll see you, man. Bye bye. Thank you.